in this episode.
Dialectical materialism isn't really something that originates in Marx. It originates in another guy, Dietzken, who was another social democratic thinker contemporaneous with Marx, and he invents the term. It later becomes the orthodoxy of German social democracy due to Dietzken's influence in German social democracy, and from that it becomes the orthodoxy in the USSR. We don't think that is actually the key to how Marx operated. Marx starts out as an atomist, as a follower of the Greek atomists. And we think that's where materialism starts. The idea that Epicurus and Lucretius had, that there were first bodies, undividable things, is valid. We now say the undividable things are quarks and gluons, etc. But that is the grounding of materialism. But what that mechanistic materialism has always done is explain things in terms of constraints which are fundamentally conservation laws. So you see this first in Archimedes and his static mechanics. It then develops in Newton. With Du Châtelet, you get the idea of conservation of energy. In Newton, you get the conservation of momentum. And these ideas are explicitly what Marx says he's going to use in Capital. He's wanting to discover what he calls the laws of motion of capitalist society. And that is an explicitly Newtonian, not a Hegelian term.
Hey everyone, welcome to my conversation with the computer scientist and economist Dr. Paul Cockshott. He's probably one of the best known proponents of scientific socialism, and I think this is certainly the case for the general public. And if you look at the breadth of his work, he truly is a multidisciplinary researcher working through Marxian theory, computer science, and of course, computer hardware engineering. After studying economics, he earned his PhD in computer science from Edinburgh University. He was named on 52 patents. His research covers political economy, robotics, computer parallelism, 3D TVs, foundations for computability, and data compression. He is the author of numerous books, such as perhaps his magnum opus, Towards a New Socialism, How the World Works, Computation and Its Limits, which I highly recommend if you're interested in the philosophy of computer science, and his most recent book, Defending Materialism. And in this episode, we discussed this new book of his, Defending Materialism, and he outlined why materialism is in fact mechanical and not dialectical. Very interesting. And on top of that, I brought up a point made by Yanis Varoufakis on having markets without capitalism, and Dr. Cockshott, he had his own critique of that. Moreover, we discussed centralized planning through the lens of scientific socialism and if there are any limits to such planning from an engineering perspective. And on top of that, we touched on the genesis of Dr. Cockshott's research interest in scientific socialism. Given how extensive his research is, we certainly couldn't delve into everything. I would have liked to delve a bit deeper into certain concepts and ideas he had. However, we did have a time limit, so I certainly am hoping to invite him on again for further discussions on the podcast. I do want to explore a lot more the relationship between computability and economics and economic planning. I think that's a fascinating topic. However, as I did mention, we did have some time limits, but I'm sure we'll get another opportunity. With all of that being said, before we get to the episode, a quick PSA. As you may know, I've mentioned multiple times I'll never have advertisers or sponsors on this podcast. Frankly, I think we live in a society of excess and overconsumption, and I don't want to contribute to that by selling you more things. That being said though, forgive me for the tautology. We, for better or worse, live in the world we live in. I run this podcast on top of doing a full-time job while doing my master's, and if I am to sustain this project, I need some kind of financial backing. So if you have the means, please do consider financially supporting this podcast through Patreon, Substack, or PayPal. All the links will be in the show notes. And if you're wondering, what are the perks? What are you going to get? The honest answer is nothing. That's right, there's no exclusive behind the paywall perks. You're simply supporting this project if you think the already free content that's publicly available is of any value to you. I sincerely do want to thank the existing supporters on Patreon, Substack, and even PayPal. However, if you're considering supporting the project, please do so only if you have the means. All right, back to the episode.
Yeah, I guess before we get going, one thing I'll mention, Dr. Cockshott, is that like the audience generally they aren't experts in economics, nor in the history of science and philosophy. But I should also mention that this is not primarily like a Marxist leftist podcast. Therefore, they probably aren't too familiar with Marx and economics too, including myself, of course, in this regard. So a lot of my learning has come from, in fact, your YouTube kind of lectures and videos on your own channel. But on the note, I would say a lot of the people certainly are familiar with, I would say, with computer science and that field, this audience. Yeah. So yeah, you're an interesting combination. If you could tell us, perhaps speaking a bit on a biographical note, both as a computer scientist and an economist, what do you consider yourself first? Are you an economist first or a computer scientist first? And then follow from that, what do you see the relationship between these two fields?
Well, sequentially, I started out training as an economist. And I wanted to be able to build simulation models of the economy and also to process large quantities of, or what by those days were large quantities of economic statistics. And I was getting fed up with trying to do it with a borrowed four-function calculator, because you've got to realize I did my economics degree in the early 70s. Okay. The aids I had to calculation in those days were a slide rule, which I quickly found was too inaccurate to do any significant economic calculations, or a thing called an AddMaster, which was looked like a size of a pocket calculator. It was really no better than an abacus. It was mechanical. And I tried to buy myself a four-function calculator when Sony came to display these at the university, but they were £200, which was half my year's student income. So there was no chance of that. The year after I graduated, and I was trying to do time series analysis of the British economy, a Greek friend who was an economics student lent me his four-function calculator. So that was the first time I started actually being able to process some statistics. And I soon realized that this is not going to work. You need to actually get access to computers to do this. So I went and got a job. I was working as a school teacher at the time, didn't like it, teaching economics. And I went and got a job in the post office, applying to be a computer programmer at the post office. As it turned out, that wasn't great either, and I went to do a computing degree. And from that point on, I had access to computers, and I could do economic analysis using computers, and I could do economic simulation using computers. And this would have been about 75, and it also meant it was much easier to get a job because there's far more demands for computer
Yeah.
personnel than economists. So I ended up working for a hardware company, ICL, which was the main British competitor to IBM, at in their hardware design labs in London, in Manchester. So I was an economist first, and then a computer scientist. I later went and did computer science research, and that became my effective career.
So I assume
So
all of
first I was an
this.
economist, then a computer scientist.
Yeah, so I assume all of this was the build up to perhaps your best known work, which is Towards the New Socialism, and kind of you working within this tradition of scientific socialism. And even though when I reached out to you, I want to discuss your latest book, Defending Materialism, I can't not ask you about probably your best known work, which is Towards the New Socialism. So how did that book come to be?
A combination of two things. On the one hand, in the late 70s, I was a research associate at the University of Edinburgh, which was the probably first or second centre of computer science research in Britain. And among the people I met there were Chinese students who'd been sent over in the first wave of people after Mao died to come to the West to study science. And one of them got talking to me and said, with the background you've got, you should come and be a visiting scholar in the Chinese planning department. I thought, oh, that sounds interesting. But as it later turned out, that was too national security for any foreigners to be employed in. But it did get me thinking. I thought, okay, China's a very big country. If they're going to plan their economy in detail, they're going to need millions and millions of computers. And we're going to have to link these up in a way which makes the data in all of them equally accessible. Okay? So I started working on what kind of computer would you need? What kind of computer architecture would you need in order to plan an economy the size of China, or let's be generous about it, the whole world? Okay? And it was clear to me that the then architecture of computers, which was based on, remember, we're talking, what sort of era are we talking about now? We're talking about 1980, roughly. Okay?
Thatcher Reagan time.
The then architecture of computers was 32-bit machines. Okay? The IBM mainframes were 32-bit. The VAX 11780 was 32-bit, etc. It was clear this didn't provide enough data. You couldn't address the quantities of data that would be required for a whole economy in that. And also the machines were isolated. They were individual machines. They didn't share data. So my research at that stage was, how can you come up with a computer architecture that's potentially worldwide, that allows data on any computer to be equally shared, subject to various capability architecture features. And it was also in communication with people at the University of Newcastle, Australia, who were working on a similar idea called the monads machine. And I think my idea was you need at least 128-bit address space. Okay? I reckoned that you would need 48 bits for the full Ethernet address. Ethernet addresses were just coming in. Ethernet had been designed so that the Ethernet architecture was designed so it was potentially an internet address, not just a local address. So it's a 48-bit address, even though the early versions of the internet only used a 32-bit address. Xerox PARC went to a 48-bit address. So basically I was coming up with an architecture of a machine that would have a 48-bit machine number, 48 bits within machine address, and 32 bits of encryption code or capability, random numbers, associated with any object on the machine. And this is similar to the idea that the Rosenberg had for the monads machine. But I then approached ICL, who I'd worked for before. Could we design their next range of mainframes along this line? ICL said, okay, we'll give you one of our latest mainframes, which you can microcode to do this. Turned out that they didn't give us the permissions to microcode it. So I then went to Acorn, the people who produce the ARM chip now. They were just about to produce the ARM chip. And I said to them, here are my ideas for a larger scale machine. How about you give me the money to build a half-scale machine, a 64-bit address machine? And they gave me a grant to do that. And I built a 64-bit distributed address machine. And I then got hired by another company, Memex, and we started designing the full 128-bit machine. But the point is, at this stage, I was thinking as a computer engineer. I was thinking, how, as a computer engineer, do I integrate the information across the whole world into a single address space that's equally accessible? Now, this is before the World Wide Web was invented. It was before HTTP, etc.
And all the protocols.
And the protocols. Myself and Rosenberg were approaching this from the standpoint of computer architects, hardware architects. And we were thinking, how do we build this into the low-level addressing of the machine? So most of the work went into address translation units that would work with 128-bit addresses, etc. So the machine I started, that I designed for Memex, at that stage was using AMD bit slice architecture, which was what was around at the time. But then perestroika started happening whilst I was doing this hardware work. And I started thinking, do these people in Russia not know that modern computer technology would solve these problems for them? So I got together with my friend Alan Cottrell, who was a political science and economics PhD student when I'd been a computer science PhD student, and said, couldn't we write a joint book on this, explaining how you could solve the problems of the Soviet economy with modern computers? And to do that, we went back to things that Robert Owen and Marx had talked about in the 19th century, and tried to show that these ideas of an economy in terms of time become feasible with the calculation means that were then becoming available. We're now talking about the mid to late 1980s. So we wrote the book, and Alan went off to Moscow to work at Moscow State University. Or it wasn't Moscow State, one of the universities in Moscow, to try and get someone, in the hope that some Russian economists could be persuaded to publish the book in Russian. So our aim was to get the book published in Russian. I also went to Hungary to speak to people who I believed would be sympathetic to it, like Zsuzsa Ferge, and actually discovered the same thing as Alan was discovering, that the sort of most of the intellectuals in Hungary or in Russia had been completely taken over by Western ideology, market ideology, and just weren't interested in anything like this. The message that you could solve this by technology wasn't one they wanted to hear. The only favourable, we couldn't at that stage publish in Hungarian or Russian. I think it's certainly been translated into Russian subsequently, and I'm not sure how far the Hungarian translators got. There were certainly Hungarians translating it a few years ago. The only favourable response we actually got was from the Bertrand Russell Foundation, who were the people who actually published it, because we'd had a contract with New Left
In
Books
England.
to publish it, but in England, yeah. And as soon as the Berlin Wall fell, they said this no longer fitted with their commercial plans. Okay, things about planned economy didn't fit with their commercial plans anymore. So, as it happened, the Bertrand Russell Press did it, and we're very grateful to them.
Yes. So let me just ask again, fully put it out there. I assume you claim this then, but certainly now into 2025, you would claim that all the engineering problems for socialist calculation and complex economic planning, the engineering problems have been solved. Is that what you're saying, or do we still have certain limits?
The engineering technologies are certainly there. Software has got to be written. Okay, I don't think you actually need to change machine architectures now. It's arguably less efficient to run it on top of IP and web architectures, but these are so well established that it's a sensible way to go now.
Okay, great. So
the sensible way to go now is using all the architectures that have been built up, SOAP architectures, etc.
Yeah. So is this be like including like even like cloud computing, so to speak, and whatever that's there currently in the modern internet? Yeah.
I mean, the ideas that we had in the 80s of a uniform address space have not really been realized. And I think there are still conceptual advantages to that, but machine architectures are far too frozen in a small number of RISC and Intel designs now, that essentially there is no real chance to get a radically different machine architecture accepted. Because the architectures we were working on were capability architectures, which were a popular thing in the 70s and 80s, but aren't popular now.
Capability architectures, I have no idea what that is. I need to Google it and do some reading.
Okay. It's a class of machine architectures which I think were promoted initially by the telecoms industry. Okay? They were, I think it was Plessey in Britain and Ericsson in Sweden, used these types of machines as the foundations of their digital telephone exchanges. And Ericsson actually went furthest along the way of providing a uniform address space across all their telephone exchanges, using very advanced caching shared by fiber optic links. From the point of view, if you're wanting to do a forwarding mechanism for mobile phones, this had clear advantages. So the telephone industry were one of the groups of people who both worked on capabilities and distributed architectures because it met with their technical requirements. But you'd have to look up capability architectures. Basically, they're to provide protection in a way that the flat uniform address space doesn't. So that you have an object-oriented memory rather than the flat virtual address space. And
Okay.
object-oriented languages, in principle, fit well to this kind of architecture. Intel tried to pursue that with their 432 architecture, but it was appallingly badly designed, the 432.
Well, as a lover of Java, I'm glad to hear that. So, all right, Dr. Cockshott, I have two more questions on this topic of, scientific socialism, and I've been wanting to ask you this for a long time, which is the question of markets. Now, another economist like yourself that I deeply respect and I've learned a lot from is Yanis Varoufakis, and he gave this talk a while back where he talks about markets without capitalism. So in some sense, in that talk, I'm speaking very broadly here, he does say that you can still have something like a market without capitalism. Now, my hunch from reading some of your work and watching your lectures was that you are very much more towards the notion of centralized planning and, let's just say, against markets. So again, my question is, what are your thoughts on that? What are your thoughts on markets in general?
My view is, it's what you can have a consumer goods market where basically you have a state retail sector that sells things to consumers and sells them at prices at which supply and demand match. That's okay. But if you can have markets without capitalism to start out with, because the Yugoslavs had that. They had worker-managed factories which engaged in commodity production and were essentially cooperatives. But the tendency over time is for that to be undermined. It gets undermined in two ways, but basically they both have to do with the fact that in a capitalist economy, you get a dispersion of rates of return due to random factors, essentially random factors. So that if you start off with a set of worker-managed firms, as you did in Yugoslavia, you find that some of them have a sufficient return, not on capital, but sufficient levels of revenue to be able to accumulate funds to modernize. Others don't have a sufficient level of funds to modernize and have to, in some way, obtain credit to modernize. So that those that require credit to modernize end up having to borrow from the banking sector. And those that are running a surplus over what they pay out in wages end up building up deposits with the banks, which indirectly get used to modernize other ones. So although you start off with worker-managed enterprises. What tends to happen under that system is that the banking system starts to become a form of finance, and you start getting finance capital existing and
It's
exerting
inevitable.
an economic influence. Yes. So it happens, and it has to happen because you're not dealing with steady state economies. You're dealing with economies that are subject to random fluctuations and are growing and have to accumulate. So the issue is, where did the accumulation resources come from? And if they're coming from the borrowing from the banks, then essentially you're re-establishing capital in the form of interest-bearing capital. And the pressure over time comes for this to convert into share capital. So, although it can be stable for a while, it's not a long-term stable solution.
Yes.
You also have the problem of aggregate demand. There is no guarantee in a capitalist economy that aggregate demand will be sufficient to provide full employment. And unless the state actively intervenes to manage aggregate demand, you get unemployment. And one of the chronic problems of the Yugoslav economy at the time was that you did get a lot of unemployment. A lot of Yugoslavs had to migrate to Germany to find work. The worker-managed economy didn't guarantee full employment in a way that you didn't have these kinds of unemployment problems across the border in Bulgaria. So these are inherent limitations of a market economy. One of them is the aggregate demand problem and unemployment. The other is the uneven development means that you give rise to financial intermediation, which then establishes itself as the dominating power in an economy.
And leads to finance capitalism.
Yeah.
Yes. Okay. Beautiful. I'm going to do some reading on that. Great. All right. Now to get to, again, just because we are pressed for time, I'm just rushing through this. Dr. Cockshott, I'm sorry. I hope you don't mind.
Sure.
Now to get to the topic of materialism. So the book that I think I've read most recently of yours and your peers, Defending Materialism. How about we start, in fact, from the end, just to make things interesting. So in one of the
Can I just go and grab a copy?
Absolutely, go for it. Yes, please. Excellent. So I'll put an overlay also for the people, whoever that watch this podcast. Well, in 10.7, in one of the concluding chapters, chapter 10.7, chapter 10, in the conclusion.
What page is that? So I can see.
It's 10.7. So I need to let me open up my PDF.
Oh, I see. Okay, I'm using paper. Okay, I'll just look for 10.7. Okay.
Well, I can read out the excerpt that I was going to ask you about. Essentially, my reading of that chapter was that you all provide computability as a unifying framework for materialism, but then you build up to that argument by saying this, and I'm reading this out more for the listener. Our materialism is fundamentally scientific. We reject the primacy given to dialectics in the Hegelian and Marxist tradition, but recognize its power in exposing and resolving contradictions, in interrogating reality. So, Dr. Cockshott, could you explain to us what is the type of materialism that you're putting forward? Because I would say this, I think it is quite different to what I was expecting when I came to this book, knowing that it was written by, generally Marxists. So I'm curious to hear if you could kind of flesh out that a bit.
Well, our take is that dialectical materialism isn't really something that originates in Marx. It originates in another guy, Dietzken, who was another social democratic thinker contemporaneous with Marx, and he invents the term. It later becomes the orthodoxy of German social democracy due to Dietzken's influence in German social democracy, and from that it becomes the orthodoxy in the USSR. Now, we don't think that is actually the key to how Marx operated. Marx starts out as an atomist, as a follower of the Greek atomists. And we think that's where materialism starts. There was a huge prejudice against atomistic materialism in Germany in the 19th century. Enormous prejudice against it. And there was therefore pressure on someone like Dietzken, who was saying he's a materialist, not to appear to be one of these crude British or French materialists, but to have some added secret ingredient of dialectics. And I think this is a particular characteristic of the then historical moment in Germany, of a country that was rapidly modernizing to become a capitalist economy, but still retained large elements of the absolutist superstructure. And this is reflected in the ideological atmosphere in Germany, which is quite different from that which obtained in the United States or in Britain at the time, where the prejudice against materialism really was nothing like the same. And we feel that this has then led to a recuperation of elements of Marxism by what is essentially German idealist philosophy.
So you guys attack
the
Hegel here.
Hegelian strength. Yes. And this played out in the USSR in the 1920s, in the argument between the mechanists and the de Boernists, with the de Boernists being the Hegelians. And essentially, we are defending the mechanist side of that argument. That in order to understand materialism, you start out from the original idea of what exists are atoms in the void. You can call them... Atoms just means uncuttable, undividable. There are some undividable things. Now, what Dalton called atoms turned out not to actually be undividable. But the idea that Epicurus and Lucretius had, that there were first bodies, undividable things, is valid. We now say the undividable things are quarks and gluons, etc. But that is the grounding of materialism. But what that mechanistic materialism has always done is explain things in terms of constraints which are fundamentally conservation laws. So you see this first in Archimedes and his static mechanics. It then develops in Newton. With Du Châtelet, you get the idea of conservation of energy. In Newton, you get the conservation of momentum. And these ideas are explicitly what Marx says he's going to use in Capital. He's wanting to discover what he calls the laws of motion of capitalist society. And that is an explicitly Newtonian, not a Hegelian term. And
laws for sure. Yeah.
laws of motion. I mean, who talks of laws of motion? The idea of laws of motion is Galileo and Newton. And the structure of his argument about value is an argument about conservation laws. Okay? He first establishes that value is conserved in exchange. But that value is something different from what you see in an individual exchange. Because there has to be something behind it that is being conserved in these exchanges. Now, that is actually the same argument, essentially, that de Châtelet uses for why she has to posit something like energy as being conserved. If you consider the velocity with which you have to propel something upwards to reach a height h, the velocity will be proportional to the square root of h. If you consider a pendulum swinging, the velocity of the pendulum at the bottom of its swing will also be proportional to the square root of h, where you released it from. So there is something being conserved in the movement of a pendulum or a bullet flying upwards. It's free to exchange two things. We now say kinetic and potential energy. But their initial form is different. One is velocity squared and the other is height. But there has to be, if these freely exchange with one another, there has to be something common to them. And that was de Châtelet's insight. And that's why we get the concept of the conservation of energy. And it is the same argument that Marx is using, that there is something value that is conserved in all these exchanges. And how then do you explain profit? As profit appears to break the conservation.
Surplus belly.
So it cannot arise in exchange. It has to arise outside of exchange, because he establishes that exchange is a conservative system. Now, our point is that this whole form of argument is an argument that was only possible due to the advance of mechanistic materialism. And it goes beyond that, because how does he solve the problem of profit? He solves it by making the difference between labour and labour power. And now he didn't invent that. That is a transfer of the engineering concepts of the difference between horsepower and work done. He's directly transferring the ideas which were commonplace in Victorian engineering to the economy. The difference between power as the ability to perform work and work itself. And he uses that to explain profit. So he's taking ideas from mechanics to explain profit. And it's no accident that he was actually attending lectures at the Royal Institution on energy and on the conservation of energy. He took a real interest in this, and this shows through. Now, if people come to Marx and their training is in Hegel, what do they see? They see the Hegelian language.
Yeah,
if you come to
contradictions, dialectics,
he doesn't use it. contradiction, class contradiction thing, these terminology actually gets into Marxism much later. If you go through the German ideologies, there's no reference to it. If you come to it from an engineering background, you see different things. So the school of writers that Alan and I are most aligned with tend to be people who've come to it from a different background,
From an engineering
Farshid and
background.
Makova. Well, or physical science background or mathematics background. Farshid and Makova, for example, were basically in maths or the maths of physics. Okay, and well, this is what you see when you come to it from a different direction. I mean, Greg Michelson is also a professor of computer science.
Indeed, one of your co-authors in the book.
Yeah, and Katharina is a philosopher, but she's very much from the Lucretian school.
All right. We have 5 more minutes, Dr. Cockshott. So I guess I have to ask you this, which is, from everything you've said so far, and I wish we could go for longer, and I'm sure I'll reach out again in the future for more conversations. Can you just tell, for a lay audience here who have no idea about any of this Marxism, socialism stuff, why would you say that you're still aligned with the tradition of scientific socialism? That would be my last question.
Because that was the tradition of applying science to resolve the problems of society. That was what it was trying to do. And it was the tradition of trying to use technology in a way that serves the majority of the population rather than the minority. And I think that is what we're concerned with. And other people historically attempted to think through these problems, and we've learned from the solutions they attempted. I'm going to have to probably call it pretty short because I have to make sure I can set up my other call, which is due to start at 12 prompt.
That is completely fine. Dr. Cockshott, this has been great. It's been truly a privilege. I'll reach out again sometime in the future, but yeah, I'll let you know. I'll send you the raw file, and you tell me if you want me to have the video on or not.
Would you, if you are doing video, would you object if I co-released it on my channel?
Oh, absolutely. That's completely fine. Please go ahead. Yeah.
Okay.
I'd be honored.
Okay. I'll hear from you later.